experimental evidence for the existence of matter waves. So for that purpose, just what is matter wave? I am giving the definition. So every moving massive particle is associated with a wave. So that is the statement, hypothetical statement given by de-Broglie. So later on, for this statement, experimental proof arranged by Davisson and Germer and as well as G.P. Thomson. So here I am going to give the details about Davisson and Germer experiment. So in this experiment, they considered the electron beam and finally they showed that electrons behaved like a wave. They identified the diffraction pattern for the electrons. How they identified? Let us see. So that experimental arrangement you can see in this diagram. So here they considered the electron gun. So according to the voltage, different kinetic energy electrons will come. So those electrons, these people converted as a fine pencil of beam and they targeted on nickel crystal. So here nickel crystal, we know the interplanar distance, and as well as this nickel crystal we can change the rotation. By rotating we can arrange different angles, and here that electrons which are deviated or scattered, so those will be observed by using a detector. So here the scattered electrons will reach this place, so that here that detector will give some ionization current. According to that current we can identify through galvanometer. So with that we can identify the intensity of the electrons. So here electron beam we are sending, so whether electrons reached or not, that based on the current we are identifying the intensity of number of electrons. Nothing but here number of electrons reaching here, that we can identify. Like this they arranged here. So here high tension battery and all, just to arrange the electrons and to convert into fine pencil of beam and to reach the nickel target, and afterwards here the scattered electrons will be gathered here at the detector, and here you can see a circular scale. So the detector mounted on the circular scale, and the detector we can move according to our wish to different angle, and we can identify the intensity of electrons at different angle. What they identified? For example, if electron is a particle, for a particular instant angle we should identify at only one direction more intensity of electrons, and some other angle electrons should not be there. Here for example, for a particular instant angle electrons coming in this direction as a particle, so towards left or towards right we should not identify the electrons. Why? Because electron, if you treat, we are treating as a particle. Now experimentally what they identified? So here as like diffraction pattern, so electrons particle means we should identify only at a particular place more intensity, but they identified the intensity of electrons both sides of the original track. So with that means they identified the diffraction pattern of the electrons. Not only that, so here they changed the voltage. If we change the voltage, then electron velocity will change. So we are doing work on the electron, accordingly kinetic energy of the electron will come and those will hit the nickel target. So as velocity changes, momentum changes. If momentum changes, de-Broglie wavelength will change. So here for a particular wavelength only they got the maximum intensity. Actually if electron behaved like a particle, so for a particle irrespective of the velocity, all particles should reach this detector with a particular incident angle and as well as reflecting angle. But here electron behaving like a wave, so that is why for a particular wavelength only it is giving more intensity. For other voltages it is not giving that much intensity. As a particle it should not behave like that. That means here electron behaving like a wave, so that is why we are getting more electrons only for a particular voltage. Let us see the remaining details how they analyzed. Here they applied different voltages, 40, 44, 48, 50, 54, 58, like that. They identified the intensity. The maximum intensity they identified at exactly at 50 degree scattering angle. So here phi value they identified as 50. That time they identified the maximum intensity. Not only that, that maximum intensity they identified at 54 volts only. So why? I will explain. So for that you should know the details about the incident angle and all. So for example, here according to the incident angle and from the diagram, so here you can see one straight line, this is a imaginary dotted line, so interplanar distance I arranged here. So here it's a straight line, so total 180 degrees angle, so theta plus phi, the total should be 180 degrees. That you can write like this: theta plus 50 plus theta equals to 180 degrees. So that means 2 theta equals to 130, nothing but theta equals to 65. So here theta is not an incident angle, it's a glancing angle. So for that you should know the Bragg's equation. Okay, so here crystal and diffraction on the crystal, that small concept also you should know. So for that purpose, just one diagram. For example, here consider a crystal with interplanar distance d, means distance between the atoms is d here. And for example, here with a particular wavelength lambda, for suppose X-rays with wavelength lambda are incident on the crystal surface, then afterwards the diffraction will take place between the interplanar distance if the wavelength and interplanar distance are comparable. So here if you use X-rays wavelength and crystal interplanar distance both are comparable values, so approximately 1 angstrom unit nearby. So here I showed the value also. So here diffraction takes place, and for this diffraction, first order, second order and so on. So in general we can write that a diffraction pattern equation, Bragg's equation, that is 2d sin theta equals to n lambda, means the 2d sin theta equals to lambda or 2 lambda 3 lambda. So like that for different wavelength it will satisfy. So first order, second order, third order, or for a fixed wavelength different angles will be possible. Okay, so here n changes, theta changes for a fixed wavelength. So for a particular wavelength different deviations possible. What I explained here, as a particle only one deviation, but if it behaves like a wave can diffract with different angles. So that is why at different angles we can identify different intensities. Let us see further how they applied to this concept. So here electrons are accelerated with 54 volts. So here for 54 volts how much wavelength for matter wave, that is direct formula derived by de-Broglie, that is 12.27 by root v. So if you substitute v value 54, then the wavelength in angstrom unit, that is 1.67 angstrom unit. So here matter wave, if electron behave like a wave, if electron here behaves like a wave, so for a particular wavelength 1.67 matter wave wavelength we got diffraction. Similarly, according to Bragg's equation, 2d sin theta equals to n lambda. So here for nickel target we know the interplanar distance 0.91, and as well as theta we identified as a 65. So if you substitute all, then here also lambda we can identify that we got 1.65. So if you observe these two, X-rays of wavelength 1.65 diffracted on the nickel crystal, at the same time electrons of wavelength, matter wave wavelength 1.67 diffracted. So here wavelength is comparable. So here X-rays diffracted, here something diffracted, means those are also behaving like a wave. So clearly here X-rays we are treating as electromagnetic wave. So electromagnetic wave diffracted, so here electron diffracted means electron behaved like a wave. So this is the experimental proof. So with this comparison we can say that electron behaved like a wave. So as like the explanation of de-Broglie according to his hypothesis, so this is the wavelength, so it is comparable with the experimental result. So existence of matter waves confirmed through this experiment. Thank you one and all.